Welcome to Ask and Learn.
Okay, so for part A here, we're using triangular numbers, which are given to us as k times k plus 1 over 2, right? So what that means is t1 is equal to 1, triangular number 2 is equal to 3, the third number is equal to 6, and the fourth one is equal to 10. Okay, well, so since t2 is equal to 3 is less than 5, which is the number of disks that we are working with, which is less than or equal to t3 equals 6, then we are going to choose, so we choose k is equal to 3. Okay, so for notation, I'm going to consider, let's say, pegs A and B. So this is moving disk, say I, from peg A to peg B. Okay, just to simplify how much I'm writing here. So the first move that we're going to do involves moving the n minus k, which is equal to 5 minus 3. So it's going to be the second smallest disk from the first to the second peg. And so to do that, we'll start by moving our smallest disk to peg 3, because we want our second smallest disk at peg 2, so we skip that one. And then we'll move our second smallest disk to the second peg where we want it. And then we'll move our smallest disk on top of that. Okay, and so the next thing we want to do is move the k equals 3 largest disks right? So we had our n minus k, 2 smallest disks on the second peg, and now we're doing our k, 3 largest disks onto peg 4. Okay, so we'll start by moving the third largest to peg 4, fourth largest to peg 3, and then we'll move our third largest onto our fourth largest on peg 3. Okay, so that frees up our fourth peg, so we can move it, our largest disk, onto peg 4. Now from there, we're going to move our third largest disk from 3 to 1 to the first peg so that we can free up our second largest peg and move that to our second largest disk and move that to the fourth peg. And now we can also move our third largest, our medium-sized disk, to the fourth peg as well. So at this point, we would have on our last peg our 3 largest, and on our second peg, our 2 smallest disks. Okay, and so finally, we want to move our smallest 2 disks to peg 4. So the last part of the algorithm is to move the n minus k equals 5 minus 3 is our 2 smallest disks to peg 4. Okay, so we do that. First, we're going to move from peg 2 to peg 1 our smallest disk. That'll allow us to move from peg 2 to peg 4 our second smallest disk. And then from 1 to 4, we just have to move our smallest disk. Okay, and so now everything is stacked up. And we can note that we had 3 moves in this last section, 7 in this middle, and 3 moves in this first section. So that gives us a total of 13 moves.